My name is Rika Antonova. I'm a postdoctoral scholar at Stanford University. I work on learning for robotics. For my CI fellowship project, I am aiming to construct representations that help robots learn efficiently. And so the poster presented here was about distributional representations and learning in a differentiable way. So in terms of distributional representations for deformables, we're interested in representing highly deformable objects. And what are the challenges here? The deformables can have potentially an infinite number of degrees of freedom, which means that we cannot simply represent them by specifying the position and the orientation of the object as we would do for rigid objects. And another challenge is that they have highly complex dynamics, so we cannot easily represent that motion of the object in a lower dimensional space. So what we have with the distributional view of a representation for deformables is that we can sample points from the surface of a deformable object and represent this in a non-parametric way as a probability distribution. And what this means is that we do not need to pick a parametric family for representation. So for example, its distribution doesn't need to be a Gaussian, it doesn't need to be unimodal, and in general, we don't need to be able to write down a formula for it. And what do we get from this? So in this way, we get a representation that can be constructed from unordered samples, that is robust to noise, and that also has some favorable mathematical properties, like, for example, a proper distance metric and continuity. Ultimately, we have shown that we can use this representation to speed up solving various problems in robotics. One of them is what is called real to sim. So that's aligning simulations with reality. And to do this even faster, we're exploring use cases with differentiable simulators where we can propagate the gradients all the way back in order to achieve fast alignment between simulation and reality. And going further, what we're working on now is we want to construct a suite of environments where we have robots, mobile manipulators that can manipulate different deformables in a kind of a household setting. So for example, folding, unfolding sheets and putting tablecloth on the table, handling groceries, handling clothing. And so with that, we're hoping that robots can learn in simulation and be able to make all the mistakes in simulation instead of making them in reality, and be able to handle highly deformable objects as well.